Okay, year 12, I'm just going to make a little video now about reacting gas volumes. This is the bit I said Dr. Halliday would do, and she has made a video on it, but it's sort of on Teams, and I'm just going to make my own version here on YouTube. So there are these types of calculations with reacting gas volumes. Now normally when you see gas, you think PV equals nRT, in other words the ideal gas equation. But there are some gas calculations where you are not expected to need to use PV equals nRT because you don't need to. You'll notice these questions because you don't get given R, or you don't get given all of the information you need. And you may have come across some of these questions before when you've looked at exam papers. So it says here, if we read this through carefully, the volume of a gas depends on its temperature, the pressure, and the number of moles, which is N. So if you've got a higher temperature, that would increase the volume, and so on. All this is saying is the volume of a gas depends on P, T, and the number of moles. What the gas is doesn't affect its volume. So nowhere in here does it say that we're looking at the MR or anything like that. It's the moles of any gas. So the volume the gas occupies is totally independent of the gas that it is. So if you have 1 mole of hydrogen, that will take up the same volume as 1 mole of CH4, as 1 mole of CO2, of any gas. So this says that if you're keeping the temperature and the pressure the same under the same conditions of temperature and pressure, 100 centimeters cubed, just as an example, of one gas will have the same number of moles of 100 centimeters cubed of any other gas. So 200 centimeters cubed of one gas will have the same number of moles of 200 centimeters cubed of another gas, and so on and so on. So what this means is, so it says here, what volume of oxygen reacts with 100 centimeters cubed of butanene? Well, here is butanene. And what this tells us is that 1 mole of this reacts with 6 moles of this to make 4 moles of this and 4 moles of this. Now we've just said above that a mole of any gas occupies the same volume. So we can read this therefore as 1 volume of this reacts with 6 volumes of that to make 4 volumes of this and 4 volumes of this. So that means volume, we could have 1 centimeter cubed reacts with 6 centimeters cubed to make 4 centimeters cubed to make 4 centimeters cubed. And that's the little trick here. You can effectively take the mole ratio and turn it into a volume ratio. Now that's the key. So if we're told that you've got 100 centimeters cubed of butanene, that means that 100 centimeters cubed will react with 600 centimeters cubed. It will make 400 of this, and it will make 400 of this. So the question, what volume of oxygen reacts with 100? 600. That's remarkably simple. So let's do another one. So you've got 1 decimeter cubed of butanene. 1 decimeter cubed of butanene. Now what do we know? Well, that will need to react with 6 decimeters cubed of oxygen. It will make 4 decimeters cubed of this, and it will make 4 decimeters cubed of that. That's without thinking, that's just reading the numbers. So it says that 1 decimeter cubed is reacted with 10 decimeters cubed of oxygen. So here's the little trick. 1 was only needed to react with 6. We only needed 6 decimeters cubed of oxygen. But look at the question, you've put in 10 decimeters cubed. The word there is an excess. So you can see that we've got this excess of 4 decimeters cubed of oxygen. So we've put in 10, but we only needed 6. So the first thing I did, I said 1 will react with 6 to make 4 and 4. Then the question says we've put in 10. Oh, hang on a minute, that's 4 decimeters cubed too many. What volume of oxygen remains at the end? 4. Okay, so what I'd like you to do is to attempt these questions. I'm going to ask you to pause the video or stop the video and come back to it later, because that little bit of information there is enough to answer these questions. And now I'm going to go through the answers. So if you pause the video now, it'll be a good opportunity there to you go and try these questions. Please don't just listen to me going through them. because that does not have the same learning benefit. Okay, so pause the video now, and then I'm going to go through them. All right, so assuming that you did pause the video, we're going to go through these answers now. In each of these questions, it says, what volume of oxygen is required to burn the following gases? So I'm bothered about the volume of oxygen. Right, so what do we know first? We know that one of these reacts with two of these to make one of these and two of these. So we're given 1 decimeter cubed of methane. So firstly, I know that 1 decimeter cubed of methane requires 2 decimeters cubed of oxygen. Okay? And this will produce 1 decimeter cubed of carbon dioxide and 2 decimeters cubed of water. So what volume of oxygen is required to burn? 2 decimeters cubed. And what volume of carbon dioxide is produced? 2 decimeters cubed. The second one then. This is a 1 to 6 to 4 to 4 ratio. So in this case, they're giving me 20 centimeters cubed. One of these reacts with 6 of these, so 20 would require 120. Just make sure I've times that by 6. I had a bit of a brain freeze there. 120 centimeters cubed. 20 times 4 will make 80 centimeters cubed, and you'll make 80 centimeters cubed. Sorry, I circled the wrong one up there, that wasn't it? 80 centimeters cubed and 120. If you've got 500 centimeters cubed of ethene, so let's just make sure we've got 2 of these react with 5 of these to make 4 of these and 2 of these. So if you've got 500, what you're going to need to do to work out the amount of oxygen, you're going to have to scale that up with a 2 to 5 ratio. So I would divide this by 2, which will give me 250, and then times it by 5, 1,250, I think. Check my math there, please. 2 of these will make 4 of these, so that's 1,000. Are you following what I'm doing? I haven't even got my calculator out yet. All right, I don't think I need it. I might need it for this last one. All right, 2 volumes of this react with 15 volumes of this to make 12 volumes of this and 6 volumes of this. Remember why this is? Because it doesn't matter what the gas is, it occupies the same volume. I've just noticed these are liquids down the end, so you can't actually do that. So, 750. All right, we've got a bit of a 2 to 15 ratio here. I'm not going to do that one in my head. You're going to have to divide it by 2 and times by 15 to work out that. And then 2 to 12, so that's a 1 to 6 ratio to give you that. Okay. I hope they're all right. The answers are in the back. Right then, next one. When 100 centimeters cubed of hydrogen bromide, 100 centimeters cubed of hydrogen bromide reacts with 80 centimeters cubed of ammonia, a white solid is formed and some gas is left over. Well, there's the white solid, and it says, and some gas is left over. All right. One of these reacts with one of these. I think the tone's just gone, so I've got a lesson now. I'll have to finish this in a minute. 1 mole of this reacts with 1 mole of this. Can you see, therefore, that 80 of this will react with 80 of this? That means you're going to have 20 centimeters cubed left over. All right? So the answer is 20 centimeters cubed. They react in a 1-to-1 ratio, so you needed 80 and 80. You've put in 20 too many. I'm going to pause this video now and finish it in a minute. Okay, so I'm just finishing off going through these now. Just going to get a little book actually to write in. So, where's the book? Here's the book. With this one at the end, I think you probably get the idea that these are just basically limiting reactant questions now. I'm going to write question 3 here. CH4 gas, so methane reacts, 1 mole of methane reacts with 2 moles of oxygen to make 1 mole of carbon dioxide plus 2 moles of liquid water. So gas volumes means that 1 volume of this reacts with 2 volumes of this to make 1 volume of this. So what have they said? 100 centimeters cubed of methane, 100 centimeters cubed, was reacted with 500 of oxygen. So let's just pause there. 100 needs 200 centimeters cubed of oxygen. you will make 100 centimeters cubed of carbon dioxide. So that's the first thing I'm going to do. 100 reacts with 200 to make 100. Now the question says that they've put in 500. So if they've put in 500, that means they've put in 300 centimeters cubed excess. So 300 centimeters cubed of the oxygen will do nothing. So there's the 500 there. 200 of it will react. 300 will just go straight through and do nothing. So the question says, what is the total volume of all of the gases at the end? So the CH4 all gets used up, this 200 all gets used up, and you're left with 100 of CO2 plus the 300 of unused oxygen. So the answer is 400 centimeters cubed. Okay, hope that's okay. Question 4. I'm just going to write it out. 2 moles of H2S, hydrogen sulfide gas, stinks of eggs that. Reacts with 3 moles of oxygen gas to make 2 moles of steam, H2O gas, plus 2 moles of sulfur dioxide gas. So it's a complete gas equation. So I'll do it again. 2 volumes react with 3 volumes to make 2 volumes plus 2 volumes. What do they tell me? If 4 decimeters cubed of hydrogen sulfide, so they're giving me that, is burned in 10 decimeters cubed of oxygen, so they're giving me that. I'm just going to write this down like this time. What is the final volume of the mixture? Give the volume of each gas at the end. Okay. Let's have a little look at this then. So if you've got 2 volumes of hydrogen sulfide, you need 3 volumes of oxygen. So actually, I'll just put that away now. If you've got 4 decimeters cubed of this, you need, I'm going to divide it by 2, you need 6 decimeters cubed of this, because they're in a 2 to 3 ratio. Oh, I've got off the screen there, sorry about that. So, I'll do that again. If you've got 4, so there's 2 react with 3. So if you've got 4 decimeters cubed of this, it will need to react with 6 decimeters cubed of oxygen. It will make 2 decimeters cubed of water and 2 decimeters cubed of sulfur dioxide. They've given you 10 decimeters cubed of oxygen. Okay, which is 4 too much. So you will have an excess of 4 decimeters cubed. Sorry about the messiness, I just really want to go over the holidays. So there's your 10 that they put in the question. Only 6 of it will react. So the 4 will react with the 6 to make 2 and 2. So what's left at the end? Well, you're going to make 2 sulfur dioxides, 2 decimeter cubes of water, and the leftover oxygen, which is 4 decimeters cubed. So it's 4, 5, 6, 7, 8. 8 decimeters cubed with those volumes. I'm sorry if that was a little bit scrappy, but that's how you do them. They're basically a limiting reactant question. So 4, fine, I'm just going to do it again. 4 decimeters cubed wants to react with 6 decimeters cubed, but you've put 10 decimeters cubed in, which means that you had 4 decimeters cubed excess, so that won't react, but there's your 10. You're going to make 2 and 2. So what disappears? This and this disappear, so you're left with that. I know I've just repeated myself, but there we go. Right, have a nice half term. Smiley face.